Hello, welcome back. So today let's talk about processing. Okay, we have talked about input devices, so we are going to be talking about the processing devices. So the device that actually do the processing of information and the data we give the computer. So So we'll be talking about we'll actually focus on the CPU, which is the brain of the computer. That's where all the processing actually happens. So we'll be talking about the CPU that executes the instructions. We'll also be talking about the main parts of the CPU. All right, the CPU has three main parts: the control unit, the arithmetic logic unit, and the registers. So we're talking about them in details too. So in case I mention something that you've not heard before, all right, don't panic. We would always see them in the other classes we'll be taking. But the thing is that I will try to mention them. Okay. So, and it will also be nice that you watch this video again and again. Watch it at least 2 times. It will help you to digest everything that we have learned so far. So you can just go through it and watch it again so that you would understand better. When you take the class like 2 times, you understand it better than you take it once, okay? So we also talk about how processing converts the raw data into information. So let's get to it. So what is processing? All right. Processing is the stage in the computer cycle. Remember, we talked about the computer cycle, the process, the input, process, storage, and output and cycle. All right. So process is the stage in the computer cycle where the computer works on data it has received from the input devices. So when we give computer data via the input devices, whether it's sensors, cameras, whatever it is, whatever input device that we are using, the computer will take it in and then process the information, process the data, work on the data. So that is the job of the processing unit. That's the job of the CPU. So the processing stage is actually the stage where the computer works on the data it has received from the input devices. Okay? So it is like the thinking stage where the computer follows instructions to make calculations, comparison, or decisions. So the thing is that when we give the computer the data, they will use this data, um, they will follow they will follow instructions to make calculations, comparison, and decisions. So all these calculations, comparison, and decisions are made by the CPU, by the central processing unit. So it is this place that the processing is done. So in simple terms, when we give with the input, data goes into the computer. Then with processing, data is worked on by the CPU. When you give computer data, they will work on it to know exactly what you want them to do with the data. Then after doing that, they will now output the result. Okay? So central processing unit is the main brain of the computer. Is the main component responsible for processing. So the part of the computer that does the processing is the CPU, is the central processing unit. So that's why it is called the brain of the computer. The central processing unit is called the brain of the computer. All right. So it makes sure every other part of the computer works together smoothly. So the central processing unit works with the other parts of the computer, the input device, the output device, and the storage device. So the central processing unit works with all of them smoothly. The CPU does three main things. The CPU does three main things. It will fetch the instruction from memory. All right. It will decode the instruction and then it will execute or carry out the instructions like adding numbers, comparing values, or moving data. So now let me give you this thing I'm going to talk about now. We are still going to make you understand better later on. But the thing is that, of course, while you're taking this program, because we want to teach you to become a computer programmer. So as a computer programmer, you will be writing instructions that the computer would follow. That makes you a computer programmer. So computer programmers, they write instructions, they write commands, they give commands that the computer would follow. So now let me give you an example here. So when you on your phone, when you click on maybe your favorite game, when you click on your favorite game, that your favorite game, the program itself, the software itself is stored in the memory. So the CPU, once remember, and touch screen is one of the input devices. So with that touch screen, the computer, the CPU will find out, oh, what does this person really want me to do? So the CPU will process the data. All right. Once you click on your touch screen, the CPU would process the data and it will understand that, oh, you want it to run the software. You want it to start the game for you. So the CPU will go and fetch the program. All right. The CPU will go to the memory and fetch the instructions, all right, for that program. Once it fetches it, it would also decode the instructions to understand what they mean, and then it will execute the instructions. So let me give you an instance. So let's say you type in 1 plus 2 for the computer to do something for you. All right. The CPU will fetch the instructions from memory, understands decode the instructions, try to understand what do you want it to do. It would, after decoding it, it would understand that you want it to do 1 plus 2 for you. That's addition operation. Then it will go on and execute that addition operation for you. But it's okay if you don't understand what I just said now. Don't worry. When we get to computer architecture, when we get to software engineering and software, you will get to understand more of this. So just understand that the CPU will fetch the instructions, decode the instructions, and execute the instructions. Okay. So what is the role of memory in processing? The thing is that CPU also have memory. Remember, we have the storage devices, but these storage devices are also part of the computer. All right. But the CPU itself also has storage devices inside of it. So why does it need memory? Why does it need to have a memory in the CPU? So when this CPU is doing processing, processing does not happen alone. All right. When the CPU is doing processing, the processing does not happen alone. So the CPU works with RAM, random access memory. So the CPU works with the storage devices. So it works with RAM to hold data and instructions while programs are running. Don't worry, you're going to understand what we mean by programs. You're going to understand because, of course, you're going to be a programmer, so you'll be writing programs. So now the CPU works with the RAM. Now the RAM is the memory location that hold the data and instructions while programs are running. I know that this might be a bit hard for you to really understand, but if you don't understand it, no problem. Okay. But the thing is this, let me give you an example. When you open any application on your phone right now, let's say you open your favorite game. That your favorite game is a software. It is a program that somebody else has written. Somebody else has written that program, developed that software. So mostly that software, when you download it, or maybe your dad or your mom downloaded it for you, when they download it, okay, that program will be stored in memory. So once you tap on it, on that, the icon of that program, of that game, the CPU will go to the memory and fetch the program. These programs are just set of instructions to tell the computer to do something. It will go and fetch the instruction and then put it in RAM. RAM is random access memory, so to put it in RAM while the program is running. All right, I wouldn't explain further, so let me not get you confused, but don't worry, as you grow, you're going to understand better, okay? All right. So, example, when you open a game, all right, as if I know, when you open a game, the CPU processes the rules and graphics, all right, but RAM temporarily stores the data so it can be accessed quickly, just like I've told you. The CPU will go and fetch the program from memory, then store it in RAM so that it can be temporarily stored there and it can be accessed quickly. So, everyday examples of processing. When you type in Microsoft Word, let's say you're using Microsoft Word to type an essay, the CPU processes your keystrokes. So as you're typing, the CPU is processing it. As you type A, the CPU will process it and display the letter on the screen. So you use the keyboard or your keypad or your touch screen to type in something in the Microsoft Word, then the CPU will process it. Okay, so when you calculate 56 divided by 7, the CPU will go through the arithmetic logic unit. So the CPU works out the answer and shows you 8. But the part of the CPU that does this arithmetic is called the arithmetic logic unit. We'll talk more about the parts of the CPU, okay? So these are simple examples of processes. So when you tell the computer to do something for you, the CPU will process the whole thing, will fetch the instruction, decode it, and then perform the operation for you. So when you play music, the CPU processes the sound file and sends it to your speakers. So now let's say you have music on your phone. When you tap on the icon to play the music, the CPU will go and fetch the place. Remember, the music's already stored in your phone. So the CPU will go and fetch that sound file wherever it is stored in the memory, then fetches it, processes it, and start send it to your speaker so that your speaker will start playing it. Okay. So when you play a game, the CPU processes your movements, your actions, and your results instantly. So as you're playing the game, maybe you're playing a car race game, as you're doing all those things, driving the car, the CPU is processing it instantly, immediately. So it is the CPU that does all the processing. Okay, so that is the CPU is where the main work is done in the computer. So why the CPU is called the brain of the computer? Why is the CPU called the brain of the computer? It is very simple. All right. Just like human brain, the CPU receives information, interprets the information, and makes decision and gives instructions. All right. So the CPU, how does the CPU receive information? The CPU receives information through the input devices. So once it receives the information or the data, it will interpret it to understand what we ask, what the input device asks the CPU to do. Once it interprets it and understand what the user wants it to do, it will make the decision and then execute the whole thing. So without the CPU, the computer cannot process information or function. So remember, without the input device, the computer cannot receive data. So, but without the CPU, the computer cannot process information or function. All right. So this is it. So what are the characteristics of processing? Processing is very fast. All right. The way CPU processes information is very, very fast. So modern CPUs process billions of instructions per second. In just a second, the CPU processes billions of instructions. Now, you might not understand what we mean by instructions, but don't worry. When we get to computer architecture, we are going to break everything down so that you understand what we mean by instructions. Okay? So, the processing is always accurate. They carry out instructions exactly as programmed. So you can see now, the CPU carries out instructions exactly as programmed. So you as a programmer, you are the one that will program the computer on what to do. You're the one that will give computers instructions. You tell the computers what you want them to do when you write a program. So don't worry. In your third month, we'll start writing programs. We'll start writing instructions, telling the computer to do something for us. So in your third month, you will start writing programs. So, but for now, let's just understand the small things that go behind the scene when we write programs, okay? So the processing is also logical. They can compare, they can decide, and they can follow rules. So processing is logical. It is also central. Processing is central. It is all parts of the computer rely on processing to work together. So without processing, the input device cannot work, the output device cannot work, the storage devices can also not work. So in summary, processing is the heart of computing. The CPU, all right, has three main parts: the control unit, the arithmetic logic unit, registers, and cache. We'll talk about them in details, all right, later on. So the CPU is responsible for all processing tasks, making it the brain of the computer. So without processing, a computer would just be a boss with no ability to think, decide, or produce any result. All right. So let's take a look at the main parts of the CPU. So let's digest them one after the other. Okay. So the first one we'll talk about is the control unit. Remember, we have three parts of the CPU has three parts. The first one is the control unit, the second one is the arithmetic logic unit, and the last one is the registers. Okay? So the control unit is the part of the CPU that directs, coordinates, and controls all the activities inside the computer. So the control unit is like the traffic controller or the manager of the computer system. So the control unit is the part that tells the CPU what to do and how to do it. Okay. It does not store data permanently. The control unit does not store data permanently, and it does not perform actual calculations. So the part of the CPU that stores data is the registers, and the part of the CPU that performs actual calculations is the arithmetic and logic unit. Okay, so but the control unit job is to just do control. It is like the traffic controller or the manager of the CPU. It does not store data and it does not perform actual calculations. Instead, Instead, it tells every part of the computer what to do, when to do it, and how to do it. So this is the controller. It tells every other part of the computer what to do, when to do it, and how to do it. So the fetching of instructions, the decoding of instructions, and the execution of instructions are done by the control unit. So what are the functions of the control unit? The control unit has several major functions. One of them is directing data flow. So it's the control unit that will remember it is the traffic man that directs what happens. So it directs how it directs the flow of data. So it tells data where to go inside the CPU. So it is the control unit that directs data to go to either the arithmetic logic unit or the registers or the memory. So the job of the control unit is to direct the data flow in the inside the CPU. It is its job also to interpret instructions. So, like I already told you, programs or software are stored in memory. All right. So it is the control unit that would fetch this software, this program from memory, and then interpret them. So this control unit fetches instructions from memory and interprets, that's decoding them. So it will fetch them, it will decode them, so the CPU knows what to do. So after fetching it, it will decode it to understand what the instructions really want the computer to do. And once it understands it, it will now direct it to either the arithmetic logic unit or to the memory. So another function is also, it is the job of the control unit to control the hardware. It sends signals to input, storage, and output devices to ensure they work in sync. So it is the job of the control unit that to control input, storage, and output devices so that they can be working together. It is also the job of the control unit to coordinate CPU activities. So anything that has to do with coordination, management, directing, anything at all, it is the job of the CP of the CU, that's control unit. So the control unit ensures that the arithmetic logic unit, the memory, and the registers work together smoothly. So it is also the job of the control unit to maintain order. So you can see that the control unit is the manager, is the controller. All right. Makes sure instructions are carried out in the correct order, one step at a time. So anything that has to do with controlling or managing this computer, it is the job of the control unit. So what are the steps of control unit operation? So how does the control unit operate? This control unit works in a circle called the instruction cycle. So the instruction cycle, don't worry if you don't understand what I'm going to be explaining now, but you will understand it as time goes on. Or even if you watch the video again, you will understand better. So the instruction cycle is they fetch the instruction, they decode the instruction, and they execute the instruction. But don't worry, you're going to understand better when we start talking about computer architecture. So basically, the instruction is just the program that we write. So when we start writing programs, you're going to understand how the computer executes the program that you write. So the CU, that's the control unit, works in a circle, and the circle is called the instruction cycle. It will fetching the instruction, decoding the instruction, and executing the instruction. So the fetch is the CU gets an instruction from the computer's memory. It will decode it to understand what what the instruction is. Now remember, we programmers are the people who write these instructions. So when, like I said, when you start your game, when you start your game as a software will be loaded in the RAM. random access memory. So when you, as you're driving the car, all right, all those things you're doing, you're actually doing some instructions. So the computer will fetch the instruction that you asked it to do, decode it to understand what exactly do you want it to do. Do you want it to accelerate, speed up, or do you want it to slow down? So once it decodes it, then it will now execute it. So it will now send control signals to the arithmetic logic unit, memory, and other components to carry out the action. It is not the control unit that carries out the action, all right? But it will send signal telling the part of the CPU that will actually carry out the action what to do. Okay. This instruction cycle happens millions or even billions of times per second in modern CPUs. Like I said, you're going to understand better as we go on, okay? So everyday examples of CU. CU means control unit. When you press a key on the keyboard, the CU directs the data to the correct place for processing. So when you remember, the keyboard is your input device. So when you input data, the CU will direct that data to the correct place for processing. And when you open a file, the CU coordinates between memory and storage to fetch the data. All right. So when you are playing a game, the CPU keeps track of instructions like movement, scoring, graphics, and ensures that everything happens in the right order. Okay. Don't worry. You'll still be creating your own game very soon. Characteristics of the control unit. It does not process or store data permanently. It doesn't process or store data. So the processing of the data is not really done by the CPU. Its job is to determine, understand what the instruction wants it to do. Then it will not direct it to the right device that will do it. It generates timing and control signals to manage the CPU. Okay, it ensures smooth communication between input processing and storage and output devices. It works continuously as long as the computer is running. So as long as your computer is running, as long as your computer is working, the CPU is always working. So what is the importance? Without the CPU, the CPU would be like a body without a brain. So you can see that the main brain of the computer now is the control unit, which is inside the CPU. Okay, so the arithmetic and logic unit cannot do calculations. So because it is the control unit that will tell the arithmetic and logic unit what to do, how to do it, and when to do it. So the registers cannot even store data. So without the CPU, there's nothing for the computer. So, but without the CPU to direct everything, the CPU cannot function. So without the CPU, the control unit, the CPU cannot function. So the CPU is the command center of the CPU. That means the CPU, the control unit, is the command center of the whole computer. So the main brain of the computer is the control unit. So in summary, the control unit is the manager of the CPU. It is responsible for fetching, decoding, and executing instructions by sending control signals to all parts of the computer. Okay, so it does not calculate, it does not do calculations, but make sure every component of the CPU and the computer system works together properly. So it is not the job of the CPU to do the main thing, to do the main processing, but it tells every other component what to do and how to do it. All right. So the next part we'll take a look at is the arithmetic and logic unit. Remember, the CPU has three parts: the control unit, arithmetic and logic unit, and the registers. So now let's talk about the arithmetic and logic unit. So what is ALU? Arithmetic and logic unit is the part of the computer that performs all mathematical and decision-making operations. So now, when the CPU actually decodes or determine or interprets what the user wants the computer to do, it will now send it to arithmetic and logic unit to tell it to perform the mathematics and the decision-making. Okay? So it acts like the mathematician and decision maker of the computer. So anything that has to do with mathematical things, decision making, logical, anything like that, it is the job of the arithmetic and logic unit to do that. So what are the functions of the arithmetic and logic unit? The arithmetic and logic unit performs two major categories of operations. The first one is it performs arithmetic operations. All right, so these operations include addition, subtraction, multiplication, division, working with negative numbers. Okay, so that's the first um, operation that the arithmetic logic unit performs, arithmetic operations. So the next one is the logical operations. So it performs arithmetic operations and also logical operations. Logical operations is the thinking, is the comparison and the decision making. The computer also does comparison. Okay, greater than, less than. So these are comparison, equal to, not equal to, true or false decision. So this is the job of the arithmetic and logic unit. It performs arithmetic operations and it also performs logical operations. Okay? So if there is any choice to be made, yes or no choice, the arithmetic and logic unit also performs it. Okay? So example, when you do arithmetic, 25 times 4 is equal to 100. It is the arithmetic and logic unit that will perform this multiplication operation. So arithmetic and logic unit will get 25 and get 4, do the multiplication, and tell you that the result is 100. So we also have the logic. When you ask the computer, is 25 greater than 4? If you ever ask the computer if 25 is greater than 4, it is the arithmetic and logic unit that performs this operation, telling you that it is true. Okay? So how does the arithmetic and logic unit works? The control unit will send data and instruction to the arithmetic and logic unit. Remember, the control unit will decode, will fetch the instruction that we ask the computer to perform, decode it, then tell the arithmetic and logic unit what to do. So the arithmetic and logic unit will perform the required operation, whether it's calculation or comparison, it will do it. Then the result is sent to registers or stored back in RAM. All right. So the result, when you say 25 times 4, all right, the control unit would interpret what you want the computer to do, and it will find out that, oh, you want the computer to do multiplication operation for you. So it will now send it to the arithmetic and logic unit because that's where the operation will happen. Then once the arithmetic and logic unit performs the operation, it will now send it, this control unit will now send it to registers for storage or the stored in the RAM. So everyday examples of arithmetic and logic unit at work. So when you use a calculator app, the arithmetic and logic unit carries out the addition, the subtraction, the multiplication. Anything that you're doing there, the arithmetic and logic unit will perform it. When you sort numbers from smallest to largest, the arithmetic and logic unit uses the logical comparisons to do it. So if you have a list of numbers and you want to sort them, if you tell the computer to sort it for you, it is the arithmetic and logic unit that will perform this logical operation. When a game checks the player score reach 100, it is the arithmetic and logic unit that makes this decision. So when you're playing your game and then they want to score you, and maybe, oh, okay, let me tell you something. When you're writing your test, when you write the test after taking this class, when you write your test, we will now ask the computer to, no, we have written a program, we have written an instruction. Once you click on submit, we have written some set of instructions telling the computer to score you. So the computer will score you. After scoring, you would also ask the computer if your score is up to 7/10. So it is the arithmetic and logic unit that would give us that answer. All right. So characteristics of arithmetic and logic unit, it cannot work alone. None of the parts of this computer can work alone. They need each other. So it gets direction or directive, it gets instructions from the control unit. It can't work alone. It uses registers to hold temporary data while performing operations. So as it is now, as it's doing some operations, performing some operations, it will be keeping some data on the register to hold it there temporarily. So it doesn't work alone. It can only perform one operation at a time. But this operation can be done very fast. It can perform billions of operations in a second. So it performs one operation at a time. Okay. So why is it important? Without the arithmetic and logic unit, the computer will not be able to perform even simple arithmetic like 2 plus 2. The computer cannot do it without the arithmetic and logic unit. The computer cannot even compare values. The computer cannot make logical decisions, all right? And the computer cannot, the arithmetic and logic unit is essential because all computer programs depend on math and logic, all right? So every part of the computer is needed for the computer to work. So in summary, the arithmetic and logic unit is the part of the CPU responsible for all calculations, arithmetic operations, and all comparison and decision making, the logic operations. All right? It works hand in hand with the control unit and registers, making it the mathematician and decision maker of the computer. So the last part that we'll be discussing, the registers and cache. So remember, the CPU has three parts: control unit, arithmetic and logic unit, and then registers and cache. So what are registers? So inside the CPU, there are two types of very fast memory used during processing. So while the computer is doing some processing, all right, they will be storing some data. They will be storing some data they are using to work in memory. Don't worry, you'll get to understand more as we are growing. You'll get to understand more. So there are two types of memory that are found in the CPU. The first one is registers, and the second one, we call them cache. Registers and cache. These are the two fast memory that are found in the CPU. They are much faster than the RAM. Okay, they are faster than the RAM, and they are used to temporarily hold data and instructions that the computer is actively working on. Don't worry, everything will be making more sense as we talk about the computer architecture. We are going to be explaining how the inner workings of the computer happens, okay? So think of them as the scratch pad or notepad of the CPU. So these are the places that the computer can store small data they are using. And this thing will make more sense if you start programming. Don't worry, you will soon start programming. You soon start writing code, okay? So registers. Registers are tiny storage locations inside the CPU that hold data. They are used to hold data, instructions, and addresses temporarily. So the job of this register is that they are used to hold data temporarily in the CPU. These registers are found in the CPU, not outside of the CPU. They are found inside the CPU. So what are their functions? They are used to store numbers during calculations. So when the CPU is processing, doing some calculations, they will be storing, especially at the arithmetic and logic unit, when they are doing those calculations, they will be storing some data in the registers. They hold memory addresses. Okay, don't worry, you're going to understand what we mean by memory addresses later on when we talk about the computer architecture. Okay, and in case you don't understand something, please reach out to us. Okay, so they store instructions fetched from memory. All right. So most of the instructions that we will be writing as programmers, they will be stored in the memory. So it is the registers that store these instructions that the CPU or the control unit fetches from the memory. They act as a working desk for the CPU. So examples of common registers, we have the register we call accumulator. All right. I'm just going to mention them here. I'm not going to discuss them further. But once we start talking about computer architectures, we are going to mention them. And once we also start talking about storage devices in details, all right, we'll also mention them. So we have accumulator, we have program counter. Well, we are going to tell you what all these things do. But don't bother in case you don't understand anything. You don't need to cram anything. Okay, but you're going to see them later on. Accumulator, program counter, instruction register, memory address register. All right, I'm already excited about the computer architecture class that we'll start having. You're going to understand what all these things do and how they do what they do. We also have memory data register. Okay, so but you can just pause the video and see if you can understand what they do. The accumulator holds the result of arithmetic and logic operation. I don't want to explain this because you might not really understand them for now. So, but when we now get into computer architecture proper, you get to understand better. Okay, all right. So we also have the cache memory. So cache memory is a small high-speed memory located between the CPU and the RAM. All right. So RAM is also a memory device, a storage device. It's a memory also. But the thing is that I'm going to tell you why cache registers are needed in the computer. When we talk about computer architecture, you're going to understand why do we need extra memory inside the CPU when we already have memory like the RAM. You're going to understand why, okay? So it stores copies of frequently used data and instructions so the CPU can access them faster. Like I'm saying, if you don't understand this, no problem. I'm just introducing them, all right? We are not going to be asking you questions on them, all right? So functions of the cache, they reduces the time it takes for the CPU to fetch data from the RAM. All right, you're going to understand better. Okay, you're going to understand better. Why do they really reduce time it takes the CPU to fetch data from the RAM? They stop frequently used instructions to avoid repeated access to slower main memory. You're going to understand why all these things are like this. They improve overall CPU performance. So, but basically, the cache and the register, they are used to store temporal data in the CPU. Types of cache, we have the L1 cache, we have the L2 cache. You're going to understand all these things when we talk about computer memory, and also when we talk about the computer architecture. Okay, we have L1, we have L2, we have L3. All right, and then maybe I shouldn't just bother explaining all these things because already I'm seeing that it will get you confused, but there is no need bringing them up. Don't worry, we are not asking you any questions from this place in the test. Okay, so let me just skip them. Okay, so that I don't confuse you the more. So when we talk about computer architecture, the week that or the month that we discuss computer architecture and the memory, computer memory, you're going to understand better. Okay. So thank you very much. I hope I did not confuse you. All right. So, but in case I got you confused, just rewatch the video. Okay. And don't worry. 1 year later, you can even come back to this program to understand better. Okay. I'll see you in the next class. Okay. Thank you.